All right, today we're going to be learning how to balance chemical equations. I personally love balancing equations very much so. I made a step-by-step lesson on how to do it. It should be pretty simple. And the key to balancing chemical equations is to do lots of problems, and you'll become very familiar with the process, and everything becomes very simple once you do it multiple times. So, without further ado, I wanted to start out with a combustion reaction that you'll see it very often. Most likely, if you're in your chemistry class and you're starting this, you'll definitely see this either on homework or on a test. And so I just want to get this out of the way. They're actually, I think they're easier than most. So actually, they're all really easy. So let's just go into it. You start with a combustion reaction is a decomposition of a hydrocarbon reacting with oxygen to form carbon dioxide and water. So whenever you're like burning anything, like fuel on your stove or even like a campfire or in your car, you're burning some type of hydrocarbon with oxygen, and you're making carbon dioxide and water. So the step-by-step lesson goes like this. Step 1, we need to identify the number of elements on each side. So we have on this side C4, I'm sorry, CC10, no, that doesn't work. C4H10, okay. So on this side we have carbon, we have hydrogen, and we have oxygen. Similarly on this side we also have carbon, hydrogen, and oxygen. If they don't have the same elements on each side, then something's wrong, because you have to have, at least your elements on each side need to be balanced. Okay, I just want to clarify, this is our reactant side. I don't know if everyone knows that, so I'm just putting that out there, reactant. This is our product side. All right, so carbon, let's just count them. We have 4 on this side, we have 10 hydrogen, and we have 2 oxygens. So these are molecules. I hope that's clear. If you were to multiply this molecule by 2, how many would you have? Carbon, you would have 8, and hydrogen, you have 20. Okay, so that's just basic understanding. If you're going to have multiple molecules, you can multiply molecules, I guess, and there will be multiple elements of it. So on this side, 4, 10, and 2. This side we have 1 carbon, we have 3 oxygen, we have 2 hydrogen. But I want to specify that there's 1 element in each molecule on this side, and I'm going to do that by saying 2 plus 1 instead. And that's going to become important because it makes it simpler to balance when you're only looking at elements that are in 1 molecule. Like carbon is only in 1 molecule on the product side, and hydrogen is only in 1 molecule on the product side. So it becomes simpler. If you were to try to balance oxygen first, it gets difficult, and I wouldn't say impossible, but it's definitely difficult. So step 2, identify an element on the product side not in multiple molecules on the same side. So like I just said, carbon. Carbon is an element on the product side that's not in multiple molecules on the same side, right? So there's no carbon in both these. Same thing with hydrogen, but oxygen there is, and we can see that just by counting them. We can see that there is that case. Step 3, we're going to use multiplication to make number of elements equal on both sides, okay? Just get that out of the way. So let's start with carbon. You can do it with hydrogen, but I start with carbon for some reason. So there's 4 carbons over here. So if we multiply this molecule by 4, we can balance this for carbon, and it checks, or I guess they're balanced on each side. There's 4 carbon on this side, 4 carbon on this side, right? And step 4 is to repeat this step, 2 and 3, for similar situations. For example, hydrogen. So hydrogen has 2 on this side and has 10 on this side. So if we multiply this molecule by 5, we don't have 2 anymore, we have 10, right? Awesome, so our hydrogens are equal. Now we can look at oxygen. So the step 5 is balance the rest. Usually it becomes pretty easy after that. So on this side we still have 3 oxygen. No, we don't have 3 oxygen. See how when we multiplied carbon dioxide by 4, it affected the oxygen as well as the carbon. So now if we were to count 4 times 2 is 8, 5 times 1 is 5. So we have a total of 13 oxygen on the right side, and we only have 2 oxygen on the left side. Okay? So how many oxygen molecules would we need to have 13 on the left side as well? Well, you'd have to multiply it by 6.5, right? But you can't have half of an oxygen molecule. It doesn't work like that. So it needs to be even, or it needs to be a whole integer, not even. I'm sorry. It needs to be a whole integer. And when you have a 0.5 like that, we can easily fix this problem by multiplying the entire equation, both the reactant side and the product side, by 2. Okay, so let's see what happens when we do that. 2CH4H10. What am I doing? Let's see what happens when we do that. 2C4H10 plus 6.5 times 2 is 13 O2. 8 carbon dioxide plus 10 waters. So let's again add up and check to make sure that we have balanced elements on both sides. CHO. All right, so let's carbon, we have 8. Hydrogen, we have 20. Oxygen, we have 26. Carbon, we have 16, we have 8. Hydrogen, we have 10 times 2, 20. And oxygen, we have 16 plus 10, which equals 26. So yay, we're balanced. Everything checks out. 26, 26, 20, 20, 8, 8. So we're going to do another quick problem. Not a combustion reaction, because I think combustion reactions are pretty easy. You always have the same chemicals, elements. So I just want to do one with adding in a different one. So let's just see what happens. So say we had HClCl3 plus H2O reacting with, or those are reacting on the reactant side. The product side is H10 silicon 10 oxygen 15 plus HCl. All right, so let's identify and count all of the elements on each side. Hydrogen, we have 1 in this molecule and 2 in this molecule. Silicon, we have 1 in this molecule. Chlorine, we have 3 in this molecule, and oxygen, we only have 1 in this molecule. Again, on the reactant, or the product side, we have 10 plus 1. Silicon, we only have 10 in this molecule. Chlorine, we only have 1 in our HCl. And oxygen, we have 15. Okay, so we did step 1. Step 2, identify an element on the product side, not in the multiple molecules on the same side. So silicon, okay, silicon works. It's on this side. It's not in both molecules. So let's try to balance silicon on the left, on the reactant side. We have 10 here. To get 10 in this, on this side, we would have to multiply this molecule by 10, right? But this affects hydrogen here and chlorine here. So hydrogen is now multiplied by 10 in that molecule, and chlorine is multiplied by 10 here. Silicon also multiplied by 10, so we have 30 chlorines, 10 silicons, and 12 hydrogens. Okay, let's see if there's another one. We have chlorine. Okay, so chlorine, we have 1 chlorine here, and we have 30 chlorines here. So we're going to need to multiply HCl by 30. So we have 30 HCl. Cool. Now this is balanced, but we have affected the hydrogen, right? 30 more, or 29 more, but anyways. All right, so the only thing that isn't balanced, we did step 3 and step 4. Step 5 is balance the rest. So the remaining ones that aren't balanced are oxygen and hydrogen. We have 40 here, and we have 12 here. And we also have 15 here, and we have 1 here. So if you can't see the quick solution here, we can just look at oxygen, because oxygen's on this side in one molecule but not on the other. So 15, if we just made the oxygens equal, we would have 15 oxygens on the left side, and we had 15 oxygens on the right side. And let's see if that fixes our hydrogen problem. That makes 30 on the left. And let's see, we have 10 plus 30, 40. Perfect. So everything's satisfied on both sides. And that's balancing chemical equations. Hopefully this was helpful. Let me know in the comments below. If there's anything else you'd like me to do, just again leave a comment below. And thanks for watching.